Yeah, good morning to all of you. So in this class, we are going to study the method called secret sharing. Okay. So before that, I recall few things which we done earlier. Okay. So we define AN is equal to one matrix, n by n matrix. Okay. So first column is 1 and the second column is x1, x2, xn. Third column is x1 square, x2 square and so on, xn square and so on. Last column is x1 power n minus 1, x2 power n minus 1 and so on, xn power n minus 1. Okay, otherwise you can think of first column as 1 x1, x1 square up to x1 power n minus 1, right? So for example, if n is equal to 2, what happens, right? So it is 1 x1, 1 x2, correct? A3 is 1 x1 x1 square, 1 x2 x2 square, 1 x3 x3 square. So we'll denote d of x1 x2 xn is determinant of an. Goal is to find a determinant, right? Very simple. When for n equal to 2, d of x1 x2 equal to x2 minus x1, correct? So similarly for 3 it is not complicated, but you can do row operations and then we can get this part, right? Okay, so finally we'll get that x2 minus x1 into x3 minus x1 into x3 minus x2, right? In general, we can prove that determinant of x1, x2, xn is equal to, so product I is equal to 1 to n, j is equal to 1 to n, but j greater than I, xj minus xi. So you can see here x2 minus x1, x3 minus x1, x3 minus x2. So xj, where j greater than I, xi. Okay. Yeah. So we proved the result by induction on n. We done it earlier. That's why I'm going a little fast. N is equal to 2, the result is true. Suppose the result is true for n equal to k. That is, this is for any x k values. D of x1, x2, xk is equal to this part. Okay. True for any k and any k numbers, x1, x2, xk. Now consider n equal to k plus 1. Now we consider this x1, x2, xk comma x now. So these are fixed. So it is a variable. So it is a function of x, right? It is f of x. So it is equal to, by definition, it is a determinant of these things, right? So first row column is 1, second column is x1, x2, xk, and now last column, this is x. Okay, so last row now become 1 x square up to x power k. Yeah. So it is a polynomial in x of degree k. So because we have, when you are simplifying it, you'll get a polynomial of degree k, right? It has at most k roots over any finite field or any field f, right? So so now if I so for example, if I take in the place of x, if I substitute x1, right? So this is equal to 0. Why? Can somebody help me?
Two rows will be same.
Two columns will be, two rows will be same, correct? First row and last row are same. Like that, you can see that this x1, x2, up so on, xk are the roots of this polynomial fx. This I'm calling as fx, right? Yeah, good, thanks. Yeah, so yeah, this I'm calling as fx itself. Okay. So these are the roots of the polynomial, but how many roots? K roots. But it is a polynomial of degree k also. So then the fx now split like this: a times x minus x1, x minus x2, and so on, x minus xk, where a is the coefficient of x power k, highest. When you multiply it, when you expand it, then you will get the x power k coefficient. X power k coefficient is the determinant of this portion, right? That is the main crux of the proof. Okay. So main crux of the proof is that, yeah, here one, right? Yeah. So this portion is the determinant of that is a quotient of x power k. Yeah. So, but quotient of x power k is a determinant of ak only, right? So that is determinant of x1 is to xk. So now this is equal to this into now a value is this d of x1 h2 xk, but we already know by induction this is equal to this much. Now this product, so we get the answer. So this is done. Okay, so one simple example is that you take 1 2 3, how it 1 2 2 3 4. Okay, so 1 1 1 2 3 4 and 2 square 3 square 4 square, we'll go to get answer like this. Okay, now if x1 h2 xn are distinct, then an becomes non-singular matrix. Why? The determinant is xj minus xi, right? So if these xi's are different, distinct, then determinant is not equal to 0. So any doubts till now, Mehak?
No, sir.
No doubts. Okay. Yeah. Okay, no doubt. So now let f be any field. Okay, now you take x1 h2 xn belong to f, be distinct elements of f, and b1 b2 bn belong to f, need not be distinct. These are need not be distinct. Now we can collect the points x1 b1 x2 b2 and so on xn bn. So since these are distinct, there is a unique polynomial, right, of degree n minus 1 over fq of x. Okay, such that for every I f of xi is equal to ba. Okay, so there is a unique polynomial such that f of xi equal to ba. So how we need to prove that? So it is given that f of x1 equal to b1, f of x2 equal to b2, and so on, f of xn equal to bn. Now we need to show that f is unique. This polynomial is unique. So if you substitute x1, so a0 into a1 x1 plus a2 x1 square and so on, an minus 1 x1 power n minus 1 equal to b1. So like that we'll get equation, right? Now we can convert it into matrix form. Okay, we do not know these coefficients a0, a1, an minus 1. We need to find out. Our goal is to say that there exists a polynomial such that this f of x equal to ba. Okay, so let us assume the polynomial is a0 plus a11, a1x plus a2x square and so on. So we are now finding a0, a1 up to an. So but while doing that, we got a matrix form like this, right? This is now we need to figure out. But what about this now, right? So here you see that these x1, these xi's are distinct. So when these x's are distinct, this is the this is an. So determinant of an is not equal to 0. Now this is my a. Okay, so this is an and this is a and this is b, right? So now I'm going to get an equal to an a equal to b. So a equal to a inverse into b. So unique solution is there. Okay, now I'm coming to the main point. Threshold scheme, secret sharing. Okay, be ready. Are there any questions till now?
No, sir.
No questions. Okay, now let t comma w be a positive integers with the t less than or equal to w. So a t comma w threshold scheme is a method of sharing a message m among a set of w participants such that any subset consisting of t participants can reconstruct the message m, but no subset smaller size can reconstruct m. Is it okay? TW threshold scheme. So there are TW threshold scheme is means we'll share the message not as it is m. We'll do some shares and give it. Okay, to w people. W may be any number. Okay, but w is greater than or equal to t. Then if any t people come, then they can get the message, but less than t they cannot. Then we will call that as a t comma w threshold scheme. So I'll explain with one example. Choose a prime p which must be larger than all possible messages and also larger than the number of w of the participants. Yeah, any questions here? Yeah, so all computations will be held in carried in modulo p here. Okay, right. Okay, so the message m is represented as a number modulo p. Is it part clear? So message m is represented as a number modulo p, and we want to split it among the w people in such a way that t of them are needed to be reconstruct the message. Is this part clear?
Yes, sir.
Okay, so how do we go? So select, so what is our goal now? Message m has to split, and we should not give m as it is, but we'll give a portion of it or like that somehow. But if t people come together, they can get it. So how to do that? So this is an integer, okay, modulo p. Okay, select t minus 1 integers modulo p. Select s1, s2 up to st minus 1. Who will select actually? The dealer select. Who is actually the main person who is sharing the secret? That person will select some t minus 1 numbers. Okay, and he construct the polynomial. What is polynomial? S of x equal to m plus s1x plus s2x square and so on st minus 1 x power t minus 1. Is it okay? Polynomial is clear? Sonali?
Yes, sir.
Yeah. So the polynomial
So-
is what? S1, S2, ST minus 1, we choose. M is the secret. So we construct a polynomial, right? Who is constructing again? Some dealer is there who is doing all this. Okay. Now what is S0? If I substitute 0, S1 0, S2 0 square, yeah, what happens? We'll get M, right? Modulo P. Yeah. Now for the W participants, we select distinct integers x1, x2, xw, right? Modulo p. So give each person a pair xi comma yi. What is this yi? Yi is equal to s of xi. Means we are substituting xi here and we are getting yi, right? So we choose distinct integers x1, x2, xw modulo p, and we substitute them here in this polynomial. Okay, and we given it to w participants, which are given. We are giving this pair only. Means this pair is satisfying this equation, this polynomial. When I substitute x, I'll get yi. Is it okay, Mehak?
yes, sir.
Yeah. Okay. Now what we give it to W participants? What do we give? Dealer, what he gave into the participants?
Prepare xi and yi.
That much only. He not given M. He not given even the polynomial. He kept with him. For example, these numbers, distinct numbers, I can take 1, 2, W, right? 1, 2, 3, up to W is a reasonable choice for X. So we can get the pairs now 1, S of 1. I substituted 1 like the W, SW. Is it clear? Okay. So 1 to each person. So 1 S1 given to first participants, 2 S2 given to second participant, like that WSW given to the W participant. Now suppose T people get together and share their pairs, that is x1 y1 x2 xt yt. Now T people came together. Now what is their shares? X1 y1 xt yt. So they want to recover the message m, right? So we begin by linear system approach. Suppose we have the polynomial sx. See, they do not know the polynomial. Participant do not know the polynomial. Participant do not know the m. But these points, they know that they know p, and they know that these points satisfies a polynomial. So they want to find the polynomial, but degree t minus 1. If you have if you have t points, then there is a unique polynomial of degree t minus 1. That is helpful. These points will pass us through only single polynomial of degree t minus 1, right? For example, if I give 2 points, right? how many lines I can draw passing through these? Means linear equation. How many linear equations will be there? Only
One.
one. Only one. Whereas a quadratic equation, many will be there, right? So many quadratic equations may come. So right. So quadratic equations are many. So to find degree two polynomial, I need 3 points. 2 points are not sufficient. Yeah, but degree one polynomial 2 points are sufficient. Like that. Okay. Now t minus 1 degree ke liye, now I have t points. Okay. Okay. How do you do that? So yk is equal to s1 x. So yk kth one. Okay. Yk is equal to m plus s1 xk1 s2 sk2 and so on st minus an xk t minus modulo p. We'll put them in the rows. This is the one particular row, right? Yeah. So 1 xk x kth row into this is equal to y1 y2 yt. So what is that people know? They know x1 x2 x up to xt because all came together. They also know y1 y2 yt. They do not know. They do not know s1 s2 st minus 1, but they can now recover because this is all are distinct. So determinant is not equal to 0. So then we'll get by solving this, we'll get the values. Unique solution will be there. So then by s not equal to n. Is it okay? So that's way if t people, any t people come together, they can get the secret. Is it clear really? Is it you understood fully? Okay. Okay, the next thing is that we can also do by Lagrange interpolation method. What is Lagrange interpolation method? So Lk of x equal to, so you know Lagrange polynomial, right?
Yes, sir.
Yeah, so that is x minus xi by xk minus xi. Lk of x equal to Lk of x equal to, so xk minus xi. So I not equal to k. I is changing from 1 to k. So yeah, there is a small problem here. Okay. Yeah, I think there is a small problem. This is not k. Yeah, this is t. This is t. Yeah. Okay. So Lk of x equal to x minus xi by xk minus. So k is changing, right? K is changing from 1 to, so 1 less than or equal to k less than or equal to t, right? So now what happens to when I substitute Lk of xj, right? When k equal to j, so for example, let us work out with a small example. So we have x1, x2, x3. That means t is equal to 3, right? Now L1 of x equal to what, right? L1 of x equal to x minus x2 into x minus x3 by x1 minus x2 into x1 minus x3, right? Now what is L1 of x1? So x1 minus x2 into x1 minus x3. So here also x1 minus x2 into x1 minus x3, it become 1. What is L1 of x2? This
0.
is 0. This is part is there. This is constant, but here only variable is above. So L1 of x2 is 0, L1 of x3 is also 0, right? Like that. So Lk of xj is equal to 1 if k equal to j. So similarly, what is L2 of x? Can somebody tell me what is L2 of x for x1, x2, x3?
X minus x1, x minus x3, by
Uh,
x2 minus x1 and x2 minus x3.
very good, very good. Yeah. So like that, this k is changing. Okay. So the particular LK, kth polynomial, LK of xj equal to 1 if k equal to j, otherwise 0, right? Then the Lagrange interpolation polynomial now becomes d of x into yk lk of x. So what is it participants know? Participants have these xi's x1, x2, xt and y1, y2, yt. So but this x's now they don't know. So by substituting it, but we know that p of x1 is equal to y1 of l1 x1 and so on. So remaining are 0, y1 1. So it is y1 only. So it is exactly p of x equal to s of x and p of 0 equal to s of 0 equal to m. Now in this approach, we can find the value m directly. So you substitute in this polynomial, you will get this very easily, right? So here, if you substitute, you will understand that's not a big problem. Yeah, some value can be down very easily. So x0, right? X in the place of x, I substitute 0. This is minus xj by xq minus xj. So these xi's are known and y's are known, and t part people came, so I can get m directly. Yeah. So this is by Lagrange's method. This is by general approach. Yeah. So any questions? So secret can be known. Yeah. Now another approach is that. Okay, before actually discussing this, I will tell you one, right? For example, I have some number, okay, x naught. Okay, I want to share with you three people. Okay, how many are there now? Right, there are 5 people now. Okay, so I have to share with 5 people, right? But I will not share as it is, right? What I will do now? So I choose randomly y naught. Okay, then I'll get a pair x naught comma y naught. This is an element in where somewhere R2. Okay, let us assume real numbers. Is it okay?
Yes, sir.
This is secret. Okay, I'm the dealer. Okay, I'm the dealer, so I have to give to 4 of you. So total five people are there now in the meeting. So I'm one of the person. I'm the dealer. I give you 4. How I give? So in the xy plane, this is a point x naught y naught in the at some place. Correct? Are you following that? Yeah. Now, can I draw a line passing through this? How many lines I can draw passing through this? Somebody can help me? Huh? How many lines I can draw passing through this?
Infinite.
Infinite. Very good. I can draw one line like this. I can draw one line like this, right? So I give one line to. I give one line, only line only. I'll give the line equation. Okay, to Rutuja, one line equation, and I'll give another line equation to Mehak, another line equation to Sonali, another line equation to Suresh, right? So is a single person can get the point. What I gave entire line. I do not told the point. Are you following?
Yes, sir.
So, but if 2 people come together, can they get?
No, sir.
Why? If 2 people come together, so you have, for example, Suresh and Mehak came, right? Suresh, you have this line passing through this point. Mehak has this line passing through this point. Then what happens? Is it not possible to get this point now? You have this line. In this line, this point, you don't know which point it is, right? Mehak has this line. all these points she does not know exactly which point is the answer, but you came together. Then is it possible to get the point?
Yes, yes, sir.
Because it is the intersection of these two lines, right? Now, what about you and Sonali come? Then all can get, right? So what is that happening? Mehak, can you tell me now? What is happening? So how many lines can be constructed? Infinite. So how many people I can give lines? Infinite people. But what is happening when they get the message secret?
When two comes together.
Two come together. This is called 2, W threshold scheme. 2, W threshold scheme. W can be any number now. Whatever may be the W. But two people come, they can get the message. Right? So now I'm giving you 3, W threshold scheme. What we will do here? Can you predict?
It will be in R3.
It will be in R3. Okay. So let us do that. We'll go, right? So let us take a prime P and a point X0 is the secret. So choose Y0, Z0 and a randomly modulo P. We therefore have a point. So this X0, Y0, Z0 are random. Secret is X0. Okay. Now my Q is equal to X0, Y0, Z0 is a point. It is a point in 3D. I told R, but we can take modulo Q, modulo P also, modulo P. Yeah. So each person will given an equation of a plane now, passing through this Q. This accomplished as follows. Choose two random numbers. Choose A and B randomly modulo P, and then C can be constructed from here. Right? So we know the point Z0, A0, and Y0. So C equal to A Z0 minus A X0 minus B Y0 modulo P. Now this is the plane equation. Okay. So yeah. Now this is done for each person. So each person will get an equation, right? So for example, he gave it to 3 people. I can give to many people actually. So, but 3 people come together, they can do it. So what is the first person has A1x plus B1y minus Z equal to minus C1. Similarly, you see second person, third person. So we can put in the matrix form like this, right? So maybe it may not be invertible because we are choosing A and B randomly. So if it is invertible, then I can get this point, right? If this is invertible, then these are unknown now. These are known to dealer. Now these people came together, then they can get X. So it is a solution, right? X0 can be determined. Is it clear? Yes.
Yes, sir.
Yeah. So this is what secret sharing. So just let me show the book and where you can read if you want further, right? So let me share that part. Yeah. Okay. So now you see that. So this is the book. Okay, Washington. Your prescribed book only. Are you following what I'm saying? In chapter 11, 12. Okay. I'll show the book. Introduction to Cryptography and Coding Theory. Wade Trap and Lawrence Washington. Okay.
So are you sharing the book?
Oh, okay. Not sharing, right? Yes, I'll have to stop and share, right? Yes. Correct. Thanks. Yeah. So this is the book, okay? So Introduction to Cryptography and Coding Theory. So this is your prescribed book only, right? Here the chapter 12. So chapter 12 is about that. Okay. So chapter 12 is about secret sharing. Okay. Then I actually done complete today. Okay. I'll show you, right? Okay, what is happening? It's chapter 10. Oh, chapter 12. So this is digital cache. Okay, Sonali, it is useful to you actually. There is a chapter on digital cache. Yeah. So secret sharing scheme. So I taken definition also from here. T comma W, right? So this is what I told you today, right? So entire thing is visible here, right? Yeah. And Lagrange method also I told explained you. So this explained. So there is a they gave one example. Okay. So is it visible now? Are you able to see?
Yes, sir.
Yeah. So look at one problem. 3 comma 8 threshold scheme. What do you mean by 3 comma 8 threshold scheme? So we have 8 people, and if any 3 of them come, they can determine the secret. So now by using polynomial method, which degree, how much degree polynomial I had to take? What is the degree of the polynomial? 3 people come together, they have to get it, right?
Degree
Then
2.
that is degree 2 polynomial. Yes. Suppose now secret m equal to this, which corresponds to a secret, right? Choose a prime p, very big prime. Yeah, 1 2 3 4 5 6 7 8 9 0 1 3 3 is a prime number. Okay, now you took two numbers again, s1 and s2 modulo p. Okay, so let us s1 is this quantity and s2 is this quantity. He chose two numbers modulo p, and he constructed the polynomial. Who constructed Taylor? Okay, now now 8 persons are there, so he took 8 numbers 1 2 3 up to 8. Now s of 1. What is s of 1? Dealer knows M also, right? Dealer knows. First person who is sharing, he knows M also, right? So S of 1, S of 2 in this polynomial directly. S of 1, S of 1 value, S of 2 value, S of 8 value. So he gave the points, first point to, so he gave this point to the first person, second person, third person, like that, 8 persons, they gave the points. Suppose 2, 3, 7 want to collaborate to determine the secret. Okay, so then what they do, so these three people come together, so then they'll get the information, so by Lagrange's method, right? Yeah. So they can easily get the entire polynomial. Now they do not know the polynomial, but now they know that these 3 points, once we have 3 points, then there is a unique polynomial passing through them, right? So because x1, x2, x3 are distinct, so they will derive the matrix and then they will find the m. So this equation they will do, right? And so see, this is easy. So 237, 237, right? So 237. So now s1 m, s1, s2, s2 are not known, but at 2 the value is this, right? Y2 value is this, right? 237. Y3 value is this, and Y7 value is this, right? So substituted, and we'll get this matrix, and they solved it. So they will get the M also, right? And other approach is that this what I told you, right? So there is another method due to Blackley in 1979. So there are several people, and we want to arrange that 3 can find the secret. So this is the method I explained you, correct? Yeah. So there is example that much only. This chapter is over. I covered entire chapter. So there are certain problems are there. Go through them. So try to understand the concept that and the matter. Okay. So if you it is easy to follow, so that I can give one problem maybe in the exam, right? So get ready with it. Is it okay? Are you clear? Yeah. Any questions related to that?